I've lovingly repacked the motherboard into the box so that we can unbox it together again, because that's just how we roll. Today I'm taking a look at the ASRock Fatal1ty X399 gaming, or the person who bears my namesake, or maybe I bear his namesake. I don't know how that works. That's kind of weird. This is a high-end Threadripper motherboard. At the time of this video, there's really not a lot of Threadripper motherboards to choose from, and ASRock has put this together. It is a gaming Threadripper motherboard, although I would say that the Threadripper platform is not really designed for gaming. It'll do gaming pretty competently, but it does other things so much better. I mean, there are certain things that Threadripper does where it just mops the floor with the competition, and so I guess that's not, it's like the ASRock Fatal1ty X399 super virtualization, oh my gosh, amazing, whatever. That just doesn't have the same ring to it, I guess, so everybody's got to put gaming in the title. This motherboard has 60 amp chokes and 10 gigabit Aquantia Ethernet. Let's take a deeper look. So in the box you get a multi-language hardware manual and a software installation manual, driver CD and silver case badge, the ever popular ASRock Fatal1ty postcard. We've got our high-speed bridge, M.2 mounting accessories, our 3-way SLI bridge, in case you're running an older graphics card, our 4-way SLI bridge, in case you're running an older graphics card, 4 6 gigabit per second SATA cables, 2 rubber duck Wi-Fi antennas. That's kind of surprising on a higher end product. I would have expected, you know, like a cabled antenna or something like that. These antennas are fine. It's just that because the antennas will be located, you know, basically sticking out the back of the computer, you know, if you get better signal having the antenna like on top of the computer or relocating the antennas with the wires can work better. So usually on higher end motherboards you see that. We've got our rear I/O shield. Well, there it is. There's our ASRock X399 Fatal1ty Gaming. This is an exceedingly nice motherboard. So many things. So many little details, so many little things to talk about. There's 2 types of socket for the Threadripper CPU on Threadripper motherboards. One is from Lotes, I'm not sure if I'm pronouncing that correctly, and the other one is from Foxconn. A lot of people that got the Foxconn connector complain that when you are closing the socket, where you go the 1, 2, 3 screw order, because you have to screw it and unscrew it with the included torque wrench. Yes, this is an actual torque wrench with a Torx bit, but when you use the torque wrench to tighten it down, that it doesn't really want to thread. I've not had that problem personally on the one motherboard I have that has a Foxconn style connector, but I understand that some people have had that problem. Some people have reported that the actual socket screws, not the screws that you're meant to unscrew, but the actual motherboard's screws, arrive a little loose, and sometimes that causes some post errors and things like that. I haven't seen any of that personally. I do think I like the Lotes sockets better than Foxconn, but again, my experience with this is pretty limited so far. Like 3 or 4 motherboards with the Lotes socket and 2 with the Foxconn socket, so your mileage may vary. The layout for this motherboard is pretty interesting. We've got a single 4-pin 12-volt connector in the top, and then on the other side of the RAM, we've got our CPU 8-pin power. Now here's a hint. I've run into weird problems, especially when I'm overclocking Threadripper memory and also Ryzen memory, if I route the CPU power connector, like the power cable, over the RAM. As long as I clear the RAM by a decent amount, I don't have too much trouble, but I've actually had problems where I couldn't get a system to post past 2400 when I had the 12-volt cable literally just laying on top of the RAM. Moved away from there, no problem. So I wonder if that will be problematic for this motherboard for certain kinds of overclocking. Now for our testing, I used G.Skill Trident Z DDR4 3600. I could not get it to post or work at 3600, but I could get it to work at DDR4 3200 and 2933. So I'm not really sure what that's about. I don't know. It is, of course, quad channel, because if you've been living under a rock, Threadripper is quad channel. Threadripper is a really exciting CPU. You can have up to 16 cores in your desktop. You know, as I said before, I don't think that Threadripper is a gaming CPU. If you're buying a CPU just for gaming, Threadripper is not for you. You should probably look at something else. I mean, honestly, Ryzen 7 or Ryzen 5 is all you need for gaming, if all you're doing is gaming. That said, if you want the the pinnacle of awesome, this is probably it. At the top edge of the motherboard, we've got our first CPU power connector. That is a 4-pin power connector, and we've also got our first chassis fan header connector. Then at the edge of the motherboard over here on the other side of the VRM heatsink assembly, which does have a heat pipe to carry heat to the back part of the motherboard, which is a nice touch because the VRMs will get quite hot when they're dumping 250 watts of power into the processor. So there you go. We've got our Extreme OC dip switch. If you're going to do extreme overclocking, you can flip this switch and sort of override some of the safeties on Threadripper, but hey, you're taking your $700 or $1,000 processor into your own hands, so cool, you know, whatever. Then we've got another 4-pin fan header. We've got our 8-pin CPU ATX power connector. Then we've got our 24-pin ATX power connector below that. And then just below that, we've got our first USB 3.0, that's USB 3.1 Gen 1, front panel connector. Just behind that, we've got our first RGB header LED. This isn't just a standard, 4-pin RGB header LED. Then we have our 8 6 gigabit per second SATA ports and a 6-pin auxiliary power input. Now this motherboard, as I mentioned before, it does support 4 graphics cards, and potentially each graphics card can pull up to 75 watts from the PCI slots. So there's an additional 6-pin supplemental power connector here on the front of the motherboard. If you're going to run a lot of high current devices, you can totally do that. Now there are other Threadripper motherboards that have a different PCI Express layout here. The layout is by 16 by 8 by 16 by 8. And those are always by 16 by 8 by 16 by 8 because Threadripper has a ton of CPU lanes. There is one extra PCI Express by 1 connector. That's PCI Express by 1 2.0 through the chipset, through the PCH. So that's not really wired directly into the CPU. That's for low speed peripherals. Maybe you're going to add another gigabit Ethernet card or something like that. That's what that connection is for. Now at the bottom edge of the motherboard, it's got a really neat feature down here in the corner. It's got a right angle front panel audio connector. So depending on your case, and if you're going to run 4 graphics cards, they've thought of everything. So it's like you might not be able to use some of the connections along the bottom of the motherboard if you are actually going to run a graphics card, because that 4th graphics card is going to hang off the end of the motherboard. So what have they done? They've provided a right angle front panel connector for the audio. Really nice touch, ASRock. Well done. Moving along the bottom edge of the board, we've got an RS-232 serial port. We've got another RGB header connector, a 4-pin fan header. Then we've got our front panel connections, and just above that we've got a TPM header. Then we've got 2 USB 2.0 headers, a clear CMOS button, our Dr. Debug error code readout. So if you're not familiar with what this is, if the computer won't post, it'll give you a code, and you can look up the code in the manual as to why it won't post. I mean, there are helper LEDs on some motherboards, and helper LEDs and diagnostic code readouts. Diagnostic code readout can be really handy. It'll tell you things like memory error, or memory misseated, or CPU misseated, or graphics card not installed, or no boot device, or whatever. You can see some signs of life. The computer can give you some clues about why it won't boot up if you read the code. You've got a physical power and reset button, and then just below that another USB 3.0, that's USB 3.1 Gen 1, the protocol connection, and then the rest of your front panel connections. So the one in the middle is like speaker and LEDs, in case your case has a speaker, or the 3-pin power LED, but the ones in the corner are the rest of your front panel connections. There are also 2 more 4-pin fan headers just above the graphics card. The first by 16 slot just below the CPU. It might be a little tricky to use these connectors depending on what sort of a CPU cooler that you're using. If you're using an all-in-one, of course it's no problem. If you're using a tower cooler, you'll want to be sure that you install those cables before you install the graphics card, just to make sure that you've got enough room and clearance. They're not the most convenient of locations, considering the RAM and considering the issue that I had running the power cable over the RAM. I don't want to run any cables over the RAM at all, but they're there. You can use them. Now for the rear I/O on this motherboard, you've got your BIOS flash button, so you can use this to actually flash the UEFI on this motherboard. That's important because Threadripper is supposed to be a 4+ year platform, and you can better believe that they're going to come out with new CPUs that are not out today that will fit in this socket. The next version, the next iteration of stuff, Threadripper, well, it's going to be compatible with this socket, so you may need to update your UEFI. If you pick up one of these motherboards later that's been on a shelf for a while or something like that, this will let you upgrade your UEFI without having a functional processor to support a new processor. So that's a really important feature to look for on motherboards. Then we've got our combo PS2 mouse and keyboard header, which will break out if you want. You can get a Y cable to support both a PS2 mouse and keyboard simultaneously. Then below that we've got our first 2 USB 3.0, that's USB 3.1 Gen 1 ports. Then right next to that we've got our wireless solution. Now this is Not a 2x2 wireless solution. The manual says that it only supports up to 433 megabit, so that tells me that it's not a multi-in, multi-out 2x2 type solution, but it does support Bluetooth 4.2 at least, so that's a nice touch. It is Intel wireless. Sometimes Intel wireless can be a little problematic depending on what version of the drivers you get for the Windows operating system. Linux, of course, not really a big deal, works fine with Linux. Everything is good there. Next to that, we've got two more USB 3.0 headers. Then we've got our front panel audio. This is sort of an odd placement for the front panel audio because there's a whole bunch more connectors next to there, but hey, whatever works. The front panel audio is based on the Realtek ALC 1220 codec. 120 dB signal to noise ratio is what it has been designed with. We'll talk a little bit more about the audio codec in a minute. It does also have optical SPDIF out. Next to our front panel audio, we've got our 3 LAN connections. Now the red one is our Aquantia 10 gig NIC. Next to that, we've got our Intel i211AT gigabit NICs. Now, below the rightmost one, we've got our USB 3.1 Gen 2 10 gigabit per second ports as well. So yeah, 30 gigabits in that little stack right there. 2 10 gig USB and 1 10 gig Ethernet. Then the other ports are USB 3.1 Gen 1, so 5 gigabit the protocol. Now for the audio solution, it is a 7.1 audio solution. It does support the Blu-ray codecs. It's a Nichicon fine gold audio capacitors. It has a TI-NE 5532 headset amplifier. Those headset amplifiers are designed with up to 600 ohm headsets in mind. It has direct drive technology, PCB isolation, RGB LED gold contacts. It has 15 micro of gold plating, so should be durable for a lot of insertions and removals. And the software package provided supports up to Sound Blaster Cinema 3. So if you're looking for the Creative Labs Sound Blaster audio bundle audio package, it's up through Cinema 3. So there you go. Now this motherboard does have 3 onboard M.2 ports, 2 of which are 80mm, 1 is 110mm. It does support M.2 RAID, including bootable RAID, although at the time that I'm doing this video, that's not out yet. It's an announced feature from AMD, but it hasn't quite been rolled into the motherboards yet. That's expected as of September 25th, 2017. You're probably watching this after that. So the whole RAID setup, RAID testing thing is going to be a separate video from Level 1. Look for it on the Level 1 Tech's channel. It should be pretty good. But we're going to talk about RAID on this and competing platforms and that sort of thing. But this thing should stand a pretty good chance of being awesome because all of the M.2 slots are directly into the CPU. It doesn't go through a PCH or anything like that. So you're in a really good, probably the best situation that you could expect as far as the M.2 connectivity goes. Now the Linux support for these boards, I always love to talk about Linux support. Linux support on this board is pretty good. It's decent. I had some trouble getting the sensors to work, whereas I have not had trouble with sensors on the other Threadripper boards that we reviewed. And I'm not really sure if that's down to the driver or a kernel problem. Things really haven't matured a bunch on the Threadripper side of things. The Aquantia 10 gig NIC is supported in Linux, though depending on your distribution, you might have to jump through some hoops to get it working. The sound works out of the box, the Intel NICs work out of the box. Basically all of the other peripherals on the board work out of the box, with the possible exception of RGB control, but I don't think anybody on Linux expects that. All in all, it's a pretty solid experience on Linux. Really impressive, super awesome. In terms of IOMMU, a PCI Express pass-through, Threadripper as a platform, not ready for that yet. If that's something that interests you, you should follow our Level 1 Linux channel, because just as soon as Threadripper is good to go for that, we'll put out a video and it's going to be great. It looks like we're going to be waiting on some kernel updates and maybe also an Agiza update for the platform for proper virtualization and proper handling of those kind of devices. Even though I don't recommend you use IOMMU, like PCI Express pass-through for gaming, here they are for the morbidly curious. Basically everything is pretty good. On this board, it does not seem like the NVMe is grouped with PCI Express slot, although I didn't have a chance to test all the M.2s. For the system, I put in a GTX 1080, a secondary graphics card, a PCI Express by 1 USB 3.0 adapter, a PCI Express storage card, an Intel Optane NVMe, and then I looked at the IOMMU groupings. The graphics cards were isolated in their own respective groups, so they were isolated from each other and isolated from the rest of the system, which is great. But the PCI Express by 1 slot was hanging off the Promontory chipset, as is the 10 gig Ethernet adapter, as is the ASMedia USB 3.1 controllers. So literally everything was in group 13 there. that was hanging off the Promontory chipset. So your Intel NICs, your 10 gig Aquantia NIC, and the USB 3.1 controller that was an add-in card were all grouped together, which is unfortunate. Hopefully they'll fix that. They haven't fixed that on Ryzen yet. Everything off the Promontory chipset on Ryzen is also in the same group, so hopefully we'll see a fix for that soon. In terms of running virtual machines, just tons of virtual machines, assuming that you don't need PCI Express pass-through, Threadripper delivers. We did all of our testing with the 12-core, the 1920X Threadripper, and it is a joy. This platform is an absolute joy. It's great. It remains responsive even under load. You can compile the Linux kernel in like 5 minutes or less, and that's with the 16-core Threadripper. I mean, it's just, I can't say enough good things about Threadripper as a platform. There's really not a lot of motherboards to pick from for Threadripper, and this is one of the more high-end boards that you can get. But it's also, I mean, for the features that you get, I mean, 10 gigabit Ethernet, if you get a PCI Express 10 gig Ethernet add-in card at the time of this video, I mean, it's like $200-300 just for the add-in card. With the built-in 10 gig NIC, this does not move the price of the motherboard $200 or $300, so I'm very thankful for that. But, at the same time, there's not a lot of Threadripper motherboards that actually do have built-in 10 gigabit Ethernet, which is a nice feature to have when you've got a processor as fast as Threadripper. In terms of other experiences, the UEFI is a little rough around the edges. There are some bugs in the UEFI. There have been a lot of updates to the UEFI as we have been doing the video. The first version of this video was a little bit more harsh on the UEFI, but largely most of the complaints that we had about the UEFI have since been resolved through UEFI updates, and we sort of chalk that up to Threadripper is a totally new platform. It's a totally new everything. AMD, the plucky little underdog, has I don't know, something analogy. It's really amazing what AMD has done, and the board partners have done a really good job supporting AMD with stuff that's this nice, and the future is only going to get better. It's honestly, it's really exciting. So if you picked up Threadripper and you're experimenting with Threadripper and you picked this board or you picked another board or whatever, join us in the forums at Level 1 Techs. Sit down, tell us about, tell us your story, tell us some interesting stuff. Me, I'm doing a lot with Linux on Threadripper and trying real hard to get PCI Express passed through to work and all sorts of other fun stuff, so that's really, really exciting. In terms of like overclockability and other sort of niche features of this motherboard, we were able to overclock our 1920X to 4.2 because this little guy will overclock to 4.2. We have to up the voltage to like 1.38, 1.39 volts. The VRM area does get toasty, but there's this nice heat pipe for conducting heat away from the VRM area. So the VRM implementation on this board seems to be pretty good. It is an 11-phase power delivery circuit. When you're dumping 200 or 300 watts into the CPU, it's not unusual for 10-15% of that to go to waste heat. So think about how much heat a 35 watt incandescent light bulb produces. That's how much heat the power delivery area on the motherboard is going to produce, and so you're going to need some airflow to deal with that. An all-in-one cooler maybe doesn't give you enough airflow, but if you're in a smaller tower case like the Corsair Carbide 400C with some nice front fans, it'll do a really good job. Same with the Fractal Meshify C. Put some front fans in there, maybe mount your all-in-one there. There will be sufficient airflow across your VRM so that you don't really have much of a problem. I think that works out fine. I don't think a lot of people are going to be overclocking Threadripper. I mean, the wall on Threadripper is basically 4.2 gigahertz, and honestly, if you get 4.0 or 4.1, you're basically okay. Out of the box, Threadripper will automatically overclock itself with the XFR to 4.2 on up to 4 cores. So by and large, you really don't even need to mess with overclocking at all on the Threadripper platform because AMD's done a really good job just zeroing in on the bin. I mean, Threadripper comes from the top 5% of the Ryzen dies, so it's already a pretty top-end product, or made from dies that are pretty top-end. So I don't know, it's sort of exciting. It's interesting times that we live in. 2017 has been a really interesting year for hardware, and this is what we're going to have on this platform for the next 4 years. In terms of the platform functionality, we're going to get new CPUs for the socket, obviously, but this is going to be a really long-term solution. So I'm sure that we're going to see more Threadripper boards from all of the major board vendors. I'm sure we're going to see a lot of really interesting products that are based around AMD CPUs, so it's a really exciting time. I'm Wendell, I'm signing out, and I'll see you in the Level 1 forums.